Why does a stone, when lifted higher, suddenly have extra pounding force when released? Where does this energy come from? In the energy filament theory, potential energy isn't some mysterious storehouse elsewhere, it's simply how far you are from the comfortable position on a field slope map. Let's start with gravity. The tension field provides a tension terrain map for the universe. Areas pressed tightly form deeper pits, where tension is lower. When you place the stone at the bottom of a hill, it's near a relaxed valley on the map, but when you lift it higher, you push it onto a tighter, less comfortable part of the terrain. That discomfort is the gravitational potential energy. Once released, the stone slides down the slope, converting the discomfort into kinetic energy, sound, and heat. There's no need to imagine invisible gravitational energy being moved. It's just the stone returning to a more comfortable position on the tension map. The same applies to a spring, but on a different map. Instead of a space tension slope, it's the spring's internal deformation slope. The spring's natural length is the most comfortable state. When you stretch or compress it, you push the internal texture into an awkward shape, displacing it from its lowest energy state. When released, it follows its deformation slope back to a more relaxed position. Releasing energy is motion, heat, and vibration. This is elastic potential energy release. Now, think about electric potential energy. The electric field maps out a tension map for particles. Some areas are more comfortable for a charged particle. Moving the particle to a more awkward position in the field stores electric potential energy. When released, the charge moves back to its relaxed position, releasing energy as electrical current, radiation, or heat. So, potential energy isn't a catch-all energy storage. It's the set of rules for reading the map. Gravitational potential energy corresponds to the tension slope of the field. Elastic potential energy corresponds to deformation in materials. Electric potential energy corresponds to the electric field's tension map. Each field has its own comfortable valley and awkward slope, and potential energy is simply how far you are from that relaxed position. Once you think of potential energy this way, it's no longer an abstract concept but a way to understand your position in the energy sea. Next season, we'll explore what force really is. Is it the result of a particle finding its path through the terrain, or something else? Tap follow, share it on New Physics, Clear Universe.